Okay, Algebra 1 students, this video is the opening, the entry point into lesson 18.1, first lesson of module 18. And in this module, we are going to learn another way to find the solutions of quadratic equations. So in module 17, we learned about graphing quadratics, and we learned about factoring quadratics, using division to break apart these polynomials into factors that we can set equal to 0 so that we can find where y equals 0 in these equations and find out where a parabola crosses the x-axis, if it crosses the x-axis at all. So let's begin by going over some definitions and introducing a little vocabulary. So the title of this module is Using Square Roots to Solve Quadratics. And here's the form that we are going to learn about first. Okay, so previously we were able to solve x squared minus 4 by factoring. And I hope that you recognize that this is a special product. This is a difference of perfect squares. X squared is a perfect square, 4 is a perfect square, and there's a minus sign in between them. Okay? So you can solve this equation that way, but we're going to learn how to solve it a new way. You can isolate the squared term from the constant and take the square root of both sides. So let's take a look at the definition of a square root, which is right here. Okay? A number b is a square root of a non-negative number a when if you square b squared equals a. Okay? So, and here's their example. Positive 2 is a square root of 4 because when you square positive 2, you get 4. Negative 2 is also a square root of 4 because negative 2 squared is also 4. So in general, every positive number has 2 square roots, and these are opposites of each other. And you write them like this. Positive square root, also called the principal square root, and then the opposite of that. Okay? For example, the square root of 4 equals positive 2, and the opposite of that is negative 2. They want to let you know that 0 has only one square root, and that square roots of negative numbers do not exist in the real number system. They are complex numbers, and you learn about those in detail in Algebra 2. So what does this mean for quadratic equations? So what you're asking, or what you're saying when you say this, is what numbers, when squared, are equal to 4? The answer to this question is, of course, 2 and negative 2, which are square roots of 4. And the definition of a square root allows you to rewrite this equation as x equals plus or minus the square root of 4. Okay? And in general, given an equation that is in this form, you can write it as x squared equals a, therefore x is equal to plus or minus the square root of a. Okay, so let's take a look at the next part. So there are two properties of square roots that we use to solve quadratic equations. The first one is that you may break apart. This is how we simplify square roots. Now, we did a little bit of this at the beginning of the school year, but now we're going to do more of it, okay? So for a greater than or equal to 0 and b greater than or equal to 0, the square root of AB can be broken apart, and you can take the square root of each part separately, each factor, okay? If the quotient property of square roots says that if I'm taking the square root of a fraction, I can take the square root of each piece individually, all right? Same thing. So here you have x squared equals 12 and x squared equals 16 divided by 9. So let's take the square root of both sides. So this is how you get to plus or minus the square root of 12. But it is customary to rewrite these into into its most simple form. And what this means is you want to look for any perfect square factors that you can factor out of a square root. So in this case, I know that 12 has a perfect square factor of 4. So I'm breaking 12 into 4 times 3, and I'm taking the square root of each part separately. And so my final simplest form answer is 2 square root 3. So now let's take a look at the fraction part, okay? Here we have 16 divided by 9. So when I take the square root of both sides, I get plus or minus the square root of 16 divided by 9. So I am allowed to take the square root of both sides independently. And when I do that, they both simplify into integers. So my answer in simplest form becomes plus or minus 4/3. Now I just want to show you one other thing. Okay, now you can also use this method of taking square roots on both sides when a is greater than 1 and you still have a constant, okay? So what they're telling you is you can still use the same technique, all right? And this is how you do that. They've given us a problem and I've uploaded these notes. So if you want to go back and read them, you can, but I'm trying to keep this video from being too long. So I'm going to skip the scenario. Basically though, you're going to take this problem and you are going to write it in this form first, which means you're going to add 27 to both sides to get the squared part alone. Then and what this is getting at, what these questions are getting at, is that the numbers don't have to be perfect squares. It is possible for you to have irrational solutions, okay, to quadratic equations. It happens all the time. And so they're just telling you that you are allowed to have like x squared equals 5, okay? And And you can also do the same thing when you have to divide, okay? So in other words, in this situation, you're taking the square root of both sides. So you're going to end up with x equals the plus or minus the square root of 5. So here they are showing you that what you can do is you can divide both sides by a to get that squared term by itself. Okay, and so last but not least, at the bottom of the page, they're showing you that you can use this technique to divide both sides of this equation by 2 and then take the square root, and you get plus or minus 1/2 or plus or minus the 1 divided by the square root of 2. Okay? Now, you can leave this answer like this. It's totally reasonable, but you can do a technique that I'm not going to worry about for tomorrow. I'm just going to tell you we're going to talk about it later. So this is how you solve square roots. You solve quadratic equations by taking the square root. Basically, to go back to the other page, just to show you this one more time, you are going to isolate the squared part either by just kicking your constant over or kicking your constant over and dividing by another number. And then you're going to take the square root of both sides and simplify. Thank you for listening, and I'll see you in the next video.